Hello, this is John Greiner with Basin Safety Consulting and Training. This month, September 2020, we're going to be covering hydrogen sulfide awareness training as well as respiratory protection. This month's a little bit special because at the end of the month, we're going to compile all the rosters and everyone who's taken the training and send your company a physical card with your certification. So thank you very much for joining us this month, and know this one's a little bit longer, but we're going to keep it to about an hour, and the quiz is a little bit longer as well. So thank you very much for your patience, and we'll go ahead and get started. So the first part of a respiratory protection program, any respiratory protection program, is eliminating the hazards that you know are there. So for example, if you're grinding and there's smoke and debris coming off of that product or during that service, you want to take that product and ventilate it out as best as you can before you opt to use a mask. Now, for whatever reason that can prevent inhalation of that respiratory hazard, then obviously we want to use PPE. So just like all of our other protection trainings we cover, elimination and engineering controls are always the first step. So whether or not we're adding or changing ventilation, enclosing the operations, substituting materials with less toxic ones or less hazardous ones, or changing the process in which we do our work in the first place. So that's always going to be better than having to wear a mask all day. Many of us have had to wear masks the last few months, and we know that there's some other issues that can come along with wearing masks, especially if hygiene practices aren't kept. They can cause other issues long term. So we want to make sure that we can, first of all, take steps to eliminate the need for a respirator, and then, and only then, if they can't be eliminated, opt to use a respirator. Employers are responsible for a multitude of things surrounding respiratory protection. First of all, they have to provide those respirators to employees when they're necessary. Develop and make available a written company program. Most of your companies have those. If you need that, definitely reach out to us or your safety person or your supervisor, and they can get you a copy of that. Also, identify and evaluate any hazards in the workplace where a respirator may be necessary. Select and provide those based on the hazards and the type of respirator that you need. And then also, as they're doing right now, providing training on proper respiratory selection, use, and maintenance. So the program has to cover some key elements here. I'm not going to read through them all, but selecting respirators, the need for medical evaluations, who you use for your medical evaluations, fit testing procedures, use, inspection, training, and program evaluation. These are just a few of the elements covered in the written respiratory program. So once again, if you need a copy of that, or you're interested, or if you just like to read and really want to find something to put yourself to sleep at night, definitely request the written respiratory protection program, and your company will get you a copy. So there's two types of respirators out there: atmosphere providing and air purifying. So obviously with H2S, atmosphere providing is the only one that we really focus on, although air purifying does protect from H2S up to 2 parts per million. Now that's far below the permissible exposure limit of 10 parts per million, so we typically don't focus on that, but we'll talk about it briefly as far as what you use it for, because there's other elements and areas where you're going to want to use an air purifying. So the atmosphere providing does exactly that. It gives you a clean air atmosphere to breathe so that any toxic contaminants out in the air and the atmosphere do not cause any issues for you. So selecting that respirator really has to do with a few different elements. This is all NIOSH certified equipment, meaning it's been inspected by ANSI as well, been inspected and certified by those two outfits. NIOSH is a subpart of the CDC, or Centers of Disease Control, which up to this year a lot of people didn't know a whole lot about, but now you can see the amount of involvement they have in respiratory protection. We do want this because using just off the shelf, especially foreign-made equipment isn't typically going to protect you. You want to make sure that it's actually designed for the use that you're using it for and has been inspected by regulatory agencies. So the IDLH atmosphere means immediately dangerous to life and health. So every contaminant, whether it's H2S, SO2, carbon monoxide, even oxygen, has a range of how much of that contaminant in the air relative to when it becomes dangerous to your health. And we know that at that point it's going to have permanent side effects to your body and to your health. So every single contaminant has that. For H2S, it's 100 parts per million. And whenever you hit that threshold of that range, that's when you're going to need a SCBA or an atmosphere providing apparatus. You can at that point use a filter because we know we're in this significantly dangerous environment, and most filters do not protect you at that level. So in that case, you're going to want to make sure that you have an SCBA. You're also going to want to know what contaminants you're working around and what the IDLH level is. You can check that on your SDS sheets for whatever chemicals that you're working around. So the assigned protection factors, this is specifically for not atmosphere providing, but rather air purifying respirators. Essentially, they have an APF which tells you how much of whatever contaminant it's going to filter out. So just like an air filter filters out a certain amount of dust or a certain amount of other material, an APF is a measurement of how much it filters out. So higher APF means more protection. So an APF of 10 filters out a tenth of the contaminant, APF of 100, a hundredth of the contaminant, so or that's all that can pass through. So that's essentially what our APF stands for and how we determine whether or not a filter is going to protect you from what you're working around. For that reason, air monitoring, and we'll get into this a little bit later, is absolutely essential for determining whether or not your respirator is actually going to protect you from the contaminant you're working around. So there's different cartridge types out there for air purifying, and they each have a color code. Typically we see pink in the oil and gas industry because that covers us from dust such as silica, welding fumes, and diesel fuel. So those are typically the fumes that a lot of us are going to be working around. But you have black for organic vapors, green for ammonia, olive for organic vapors, ammonia as well, and then yellow for acid gases. So depending on what color you have, what APF it is, what the change-out schedule, you're going to want to look at your SDS, find the correct respirator, and then determine how long that respirator is designed to be used for before you just go, hey, I need a respirator. Oh, that one looks good. Slap it on and go to work. You definitely want to make sure that the type of respirator on the air purifying side is going to meet your needs. Another part of the respiratory protection program is medical evaluations. Now, these are not required every year. Some people do them every year, which is fine. Typically, the design of this, or the intent of the medical evaluation, is obviously to make sure you're physically capable of wearing a mask. There's no heart issues, there's no lung issues or respiratory issues, and also that you can wear one for 8 hours. If you suffer from extreme claustrophobia, wearing a mask over your face, eyes, and nose for 8 hours probably isn't a good fit for you. So a medical doctor needs to review these evaluations, make sure that you're qualified to be able to wear a mask for 8 hours and that there's not going to be any other effects by wearing that mask. Now, if you choose to use a respirator voluntarily in your company, that's perfectly okay. Especially nowadays, certain people are wearing masks, other people aren't, depending on your company policy. However, you should note that even if it is from a biological hazard, that you have to follow all the procedures of a respiratory protection program, including manufacturers' warning recommendations, sanitary guidelines for cleaning and storing that mask, as well as essentially taking care of the entire the program, that equipment effectively. So just know that even if it's not required for the type of work you're doing, you still may opt to use one, but you are still held accountable to the respiratory protection program. Now, fit testing is required annually, and there's a couple different types of fit testing out there. What a fit test is designed to do is to give you confidence that your mask works, especially if you're going to be working in a highly dangerous and volatile environment. So, if you're out there working around wells that have 10,000, 20,000, 40,000, 400,000 part per million in the air, you want to make sure that your mask is actually going to protect you. So a fit test helps you to know certainly that the brand of mask that you're using, the size of mask that you're using, fits your face correctly, isn't overly tight, isn't going to leak if you turn your head or bend over. You want to make sure that you have a proper seal, and that's the point of a fit test. And this is kind of a pass-fail deal. So there's two types of fit tests: qualitative and quantitative. So a qualitative is kind of the old school method. We'd say you put the bag over your head, you put the mask on, we fill the bag with smoke or aerosol or an acetate, and if there's a breach in your mask, you're going to taste that material. It's going to make you cough. You're going to definitely recognize that. On the quantitative side, corn oil, Negative pressure and ambient atmosphere is typically the blend that we use. This is usually done through something called a portafit or a portacal machine, and it also measures not just the pressure of the mask, but also your pulmonary function. So this is kind of fitting a couple different needs all at once. So depending on what your company uses, perfectly acceptable, but you want to make sure that whatever type of fit test you're doing meets your operator requirements or the ultimate owner operator requirements. Once a year, whether or if you determine to use a different type or size of respirator. So let's say you got fit tested for a respirator, but while you're using it, you just recognize you have to pull the straps a little bit too tight and it's not that comfortable. You want to probably change to a larger size respirator because you want it to fit well enough to obviously seal, but not so tight that it's cutting off circulation to your face or causing a headache, and that can happen, especially if you're wearing one for long periods of time. If there's any other changes in an employee's physical condition, also, whether it's weight, any sort of surgery to your face or to your, any dental surgery, you want to get refit tested as well. Typically, they're not going to change. I mean, these respirators are designed to fit a variety of different sizes of facial structures, so you'll probably be in good shape. But you still want to get refit tests just to make sure. And then also, if atmospheric hazard change, you're dealing with a different contaminant. And lastly, obviously, if a year has passed. So seal checks every time you put on a respirator are required. You have a negative and a positive pressure check. So what you do is just like it sounds, and if you wore these, you're very familiar with this. You essentially cover the regulator opening on the mask and seal it as much as you can with your hand, and you're going to breathe in for the negative pressure check and essentially suck air until you recognize that no more air can move through. You want to do this one relatively hard, and this is the easiest one to test. And typically, if it does fail, it's going to fail around the temples or right there at the bottom of the chin. On the positive pressure check, you can't breathe too hard, but you'll be breathing out, because if you breathe out too hard, it's definitely going to fail because you can overcome that pressure relatively easily. But you want to give it a good hard breath, make sure that it pops and then no air comes out once again. And you'll hear it typically if there is a release of air. So that's the best way to check your respirator. That needs to be done every time you put it on. Obviously, the importance of maintaining seals doesn't really need a whole lot of clarification, but typically facial hair or head hair coming into over the top of that seal or underneath it, that's where you're typically going to see some failure there. Also, glasses, you can't wear them with glasses, obviously, because that's going to break the seal. And then, if once again you don't have those straps tight enough, the air is definitely going to leak by. So you want to make sure you have the right proper fit. So companies are required to monitor the respiratory protection typically every year, every couple years, go through the program, make sure that all the elements are actually fitting. Typically when companies first start out, they kind of get an off-the-shelf, respiratory protection program, but then over the years you want to improve that and really implement the things that are actually happening at your workplace. So certain areas you're working, if it's around tank batteries, if it's inside of confined spaces, you want to make sure that the areas that you're working are recognized in that program and it's specific to the type of work you do, the type of contaminants you're around, etc. So that's usually about every year to 2 years you want that to be reviewed. If you have to leave the work area for any reason, you definitely want to make sure that you maintain the seal before you leave until you get to what we'd call a green zone. So usually when you're working around hazardous atmospheres, you have your red zone, your yellow zone, and your green zone. Green zones are usually the muster point or area upwind or crosswind of where the contaminant may be outside of the confined space, 10, 15 feet, typically you consider that the green zone, upwind, etc. So you want to, and then if there's any leak in that seal around your mask, or if you need to wash your faces or clear fog, once again, you also want to leave the work area to get that seal fixed or become defogged. Cleaning is pretty basic with respirators. Typically Dawn dish soap is going to be all you need. On a daily basis, you're just going to use a non-alcohol wipe. And the reason we use non-alcohol wipes is because they dry out that rubber. Once again, this equipment is made and inspected by American inspectors. However, it is made by the cheapest bidder. So some of this material is not built to last. UV can break it down. Alcohol can break it down. So you want to protect it as best as you can. And we'll talk about that on the next slide. But if you're going to wash it a little bit more in depth, so typically what I recommend is if you're going to wear a respirator every single day for a whole shift, once a week at least, you want to soak that in some hot soapy water, rinse it out, and then let it dry overnight. Let it completely air dry and good to go. You don't want to dry it with any sort of fiber-based cloth. So paper towels, any rag that has fibers. Chamois are fine if you're going to clean it and want to dry it right away. Chamois will do fine, but typically air drying is a good idea. You also want to do that with the regulator as well. You can leave that in hot soapy water for 20, 30 minutes, take it out, let it air dry, and you should be good. The reason you do this is, and this is the same thing with masks during COVID right now, is if you don't wash them, if it's a mask you use over and over again, bacteria will grow on fibers. Bacteria will grow on saliva, etc., if there's enough of it inside of the regulator or the mask. So you want to make sure that you're rinsing all that out and getting rid of it so that you don't, you're not breathing in any sort of contaminants. So same thing with your homemade masks. If they're not medical masks especially, they will capture and hold bacteria and germs on them, and you don't want to be breathing that in over and over again. So make sure you're washing your masks or replacing them if they're disposable. So storing your respirator, you do want to keep them out of sunlight, as I mentioned. You want to prevent them from being damaged, from being crushed, contaminated, obviously, by any sort of weird chemicals or materials. Moisture is not good for them. You want it to be dry. So we typically make sure that they're dry, then put them inside a bag such as this one that's designed to, it just has to be plastic. It doesn't have to be a fancy respirator bag. These are nice because they have little pull straps on them, little drawstrings, so you can kind of wrap it up around the respirator mask. And the respirator itself, or the SCBA rather, you want to also have that in some sort of hard case so it doesn't get beat up and smashed around, typically on some foam, like you can see the pluck foam here. That's going to prevent it from bouncing around inside that case because it is a soft metal that will bend, break, get dented really easily. So you want to protect that from any damage. Inspections. Now, inspections, there's two different types. There's the daily inspection you're going to do before you go to use it. And then also, you want to get it inspected and documented at least once a month. So if your company's not doing that, there's a lot of companies out there that do that. If you're using it often, you want to get it to inspect. You want it inspected once a month. If you use it once a year, maybe you just wait till that time to get it inspected once again by somebody where it's documented, and you make sure everything's working properly. So you're going to test for function, tightness of connections, proper condition, and then also any sign of deterioration of the elastometric parts, which can happen, as I mentioned, they break down in sunlight, moisture, etc. So you want to check all those things. All right, so we're done with respirator safety. Now we're going to be moving into hydrogen sulfide awareness, which is really the bulk of what we're doing training on today. So hydrogen sulfide is one of the silent killers of the oil and gas industry. It's one of the leading causes of death internationally. Although in the United States, typically we see anywhere from 10 to 20 deaths a year. Sometimes less, sometimes more. It's kind of random why that happens. So just kind of food for thought here. Most of you are going to know, but why do you think deaths occur from H2S? It isn't because people don't necessarily know it's there. 9 times out of 10, it's because they don't have their monitors on. And the signs were there, but they didn't have the right equipment to prevent them from being in a hazardous atmosphere. They didn't have anything, alarming them saying, hey, you need to get out of here. So there are numerous locations where H2S is present in the oil and gas industry. For this exercise, I'm actually going to be showing a production facility that we typically see, but on the drilling side, it can be in the cellar, it can be on the drill floor, it can be in the derrick if it's coming through pipe, it can be near the mud tanks, it can be near the shaker area, pretty much anywhere. The completion side, typically it's going to be near your breakout tanks or your flock tanks, if there's any gas, or water getting pushed there. But on a production facility, this is kind of an aerial view of one. Obviously, it can be at the tank battery. Each and every single tank's going to have a thief hatch on it. Obviously, gases can come out of there, and that's where we're going to see it, as well as at the truck loadouts when the guys are loading out water or oil. It can also be on the flow lines if there's any leaks or Vic clamps that aren't tightened properly. You may see some leaks there. Inside or outside of the treaters, on the backside where you have essentially gas going in to the treater to pressure it up to maintain proper pressure for function. If there is H2S in the gas phase, then you are going to have H2S there. And then also inside of the treater, if there's any leaks inside the treater, if any valves are open, or even if your kim rays fail and there's some gas, maybe there's gas coming out of it because the seal burst on it, then you're going to have H2S inside the treater. Scrubbers, this one right here, they typically call these Cimarron systems. They're just kind of a pre-flare, if you will, to burn off any excess gas. We've kind of moved away from these in a lot of newer facilities with the implementation of the newer flares, which is another area where we're going to see H2S. Flares do a pretty good job of burning off all the gas, but not always. And so some of that rogue gas can contain H2S and essentially escape. And then at the wellheads, of course, any loose fittings, valves, bull plugs that aren't completely tightened down. If you don't have the valves closed, or if the valve fails, you're going to have H2S around the wellhead. So these are all the areas, basically everywhere in a location where you have a valve fitting, piece of pipe that's exposed to air or the atmosphere, you're going to have a potential for H2S. So there was an H2S fatality in ND. I like to share this one only because I saw this message on Facebook. There's a 25-year-old working for a service company at a Dickinson, and a pipe broke loose inside the treater. This is a treater he'd went to many days. He's a lease operator. Goes inside the treater this day, didn't have his 4-gas monitor on. That H2S essentially overcame him just one step in, fell into the treater. Fortunately, there was someone on site to get him out. Unfortunately, after 3 days in a coma, he passed away. So it can happen instantly, can happen anywhere, especially if you have enclosed areas where H2S can be released. And this is anywhere on location, in any location. So wells can be created. It could be a sweet well today, get an improperly treated water truck out there pumping water downhole, creating bacteria, and then that decomposing bacteria can create H2S. So it can happen overnight. And we've seen changes in wells over time, especially as they get old and the production curves start to fall. They can become sour wells. So we want to talk about the use and care of monitoring devices, give some knowledge and information about applying first aid techniques and rescue techniques, knowing the existence of emergency plans and how to create those, and also, and most importantly, how to protect yourself. Just like on an airplane, what they tell you to do is before you assist the person sitting next to you, even if it's a child, with their oxygen, you want to make sure yours is linked up first so that you can actually truly and effectively administer care. So you need to be the first priority in these instances. Interestingly enough, as selfish as we say everybody is in the world, most people's first instinct is to help their buddy for whatever reason. So I want to scratch that black cloud perspective and say a lot of people go to try to help their friend first, but in this instance you're only going to put them and yourself in more danger, and then the rescuer put them at give them a harder job when rescuing you both. So make sure you protect yourself first. So we went over some of the definition here, just to kind of cover a few other ones as well. So the air supply is also called an airline respirator. There is, you don't want this more than 100 feet typically, just because that, you're going to have a little bit of friction inside there and the air pressure is going to drop. And you don't want to overpressure the hose to make sure there's enough pressure at the end of it. So the way we do that is we limit that to 100 feet, unless it's approved by NIOSH. Emergency use respirator is typically, they also call this an SRA. It's a little bag that goes over your head. Same thing, little tank. You turn it on, but instead of having a seal around your face, it creates an atmosphere around your face where you can run away. Now the one challenge of these is sometimes they're not as, like, the bag isn't very, you can't see through it very well, and so that is a little bit of a challenge. So just know that if you are using these, that if you don't know your path of escape, you may trip and fall over something. Be prepared for that. SCBA, or self-contained breathing apparatus, scuba without the U, is exactly that. It's self-contained with a sealing mask that goes around your face, eyes, and nose, and prevents any hazardous atmosphere from entering. Then we have our standby personnel. Typically, anytime you're doing work where you're going in line or breaking into a system, and H2S is over 100 parts per million, you want a standby person. Whether it's trucking, whether it's roustabouting, whether it's gas detection or measurement, you want somebody there just to make sure that if you go down, you got someone to rescue you or pull you out of the dangerous area. And obviously during work, it's even more important. So getting into responsibilities here, employees, all of us, are responsible to know the program, observe safe work practices, including the use and care of PPE and stop work authority, and also informing your supervisor of any hazards that you feel aren't properly addressed. And the unique thing about H2S is we can have a great plan written down. Emergency plan, everything looks good on paper, and we'll just use that for the whole year and every job that we do. But realistically, as all of us know, when you go to the field to do a job, there's always going to be something you didn't account for. And that adjustment is what makes us good at our job, our ability to be flexible and adapt and solve the problem. But for that reason, when we have just kind of a blanket H2S plan or H2S program, it's great. It covers most of the bases, but be prepared to adjust and make that new plan a part of the overall plan for each site and each job that you're doing. So hydrogen sulfide is also called sour gas, typically the term we use, rotten egg gas. I've even heard some people call it stink damp. I've never heard that myself, but supposedly that's something they call it. It does have a rotten egg odor, but only at very, very, very low concentrations. So we got to make sure that we really understand that. Typically, half of a part per million to 2 parts per million is where it's strongest smell. Some people can smell it up to 15 parts per million. Some people can smell it as low as a tenth of a decimal part per million, so in the parts per billion. But essentially, we just want to know very low concentrations is the only place you can smell it. It's abbreviated H2S, 2 parts hydrogen, 1 part sulfur. It's more than 8 times as toxic as carbon monoxide, kind of the other silent killer that we deal with, and is nearly as toxic as hydrogen cyanide, and 4 times more flammable than other natural gases, which I'll explain in our next. So H2S is LEL and UEL. If you pay attention to the green numbers here, every gas, just like the part per million of toxicity or part per million of how much of that gas in the air will cause immediately dangerous to life and health or fatality, it also has a percentage volume in air measuring its flammability. Most gases, propane, methane, gasoline, diesel, most of the gases we deal with have an LEL. Most of them start at 4.3%. That's our LEL. The difference of H2S is that most gases stop at about 14%, and that's their UEL. H2S goes to 46%, meaning that you can keep pumping it in and the atmosphere will still be flammable, which is especially at higher H2S wells, which most Bakken wells aren't, but some of our older Madison wells are, Mission Canyon even. You're going to see some higher levels of H2S. And that flammability is a huge issue, because even though you have an SCBA on, airline respirator, rescue tanks, the whole 9, blah, 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 if you have a flammable atmosphere, none of that stuff's going to do you any good. So knowing that, hey, our flammable atmosphere is significantly larger than other flammable chemicals and gases is extremely important to know. So less than 4.3, too lean or too little to burn. More than 46%, too much or too rich to burn. And then right there in that range is where we're explosive. Our monitors go off at 0.43% of H2S for LEL, but typically you're going to have much more present gases than just H2S. You're going to have ethane, pentane, methane, etc. in the natural gas, which usually carries H2S, so that's something to be aware of. So some other characteristics, the physical characteristics of H2S, it is about 20% heavier than air. That's called its vapor density. It's actually 1.18, but for easy use, 20% is kind of where what we say. Since it's heavier, it's going to settle in low-lying areas, sometime traveling long distances to ignition sources and flashing back, specifically through trenches. Even dikes. It can settle in those dikes and kind of go over the top, especially when there's no wind. It burns with a blue flame when it does burn, and as it burns, the oxygen is burned off, oxygen enters the equation, and you get SO2. Twice as deadly as H2S, however, has a higher dispersion rate and is heavier than air as well. Some people say, oh, SO2 is lighter than air. I don't know where they get that. If you read the SDS, it very clearly states that it is not lighter than air, but it does have a heavier, it does have a quick dispersion rate, and it is a little bit lighter than H2S. So these are some things to know. And lastly, SO2, it will burn your nostrils even at higher concentrations. So you can detect it easier than H2S, whereas H2S will just shut down your olfactory system or your ability to smell. SO2 does burn with kind of a sulfur smell. So H2S is very corrosive as well. It's soluble in water and oil because they're carbon and hydrogen based. And how much comes out of a system is relative to temperature. So what breaks H2S out of water and oil and gas is temperature and any sort of vibration or titration. So if it's moving, if it's shifting, if it's bubbling inside of a tank, your H2S is going to be released. Inside of a tank or any sort of harder metal that are typically high hydrogen content metals such as steel and iron, H2S will kind of link to that hydrogen in that metal and be absorbed. Now it can still come out. So inside of a truck tank, for example, it'll suck into the inner lining of that truck tank. You may flush it out 3 or 4 times, but on that 4th trip to the freshwater system, if you ever had sour production water in there, it can come out, and this is where truck drivers get in trouble. Now another thing it does when it interacts with that metal, if it sits in there for long enough, essentially the hydrogen goes away, that's kind of removed from the system, and you get something called iron sulfide. So the iron takes place of the hydrogen, sulfur stays there, and we'll talk a little bit about that later, but that's an issue. And that iron sulfide will break metal down. So that's something we also have to be careful of inside of wells, because it will just wreak havoc on casing, tubing, rod strings, as well as H2S down inside the hole. It'll break down that metal and cause hydrogen embrittlement. So exposure limits for a person, as we mentioned, I talked about permissible exposure limit before. That's your 10 part per million for 8 hours. Not a safe number, just to let you guys know. In a lot of countries it's 2 or 5 parts per million, but in the US it's 10. Maybe because we're stronger and tougher, I don't know. But I wouldn't call it safe. 15 is considered your short-term exposure limit, meaning like 5-10 minutes, get out of here. And 100 parts per million is your IDLH. That's once again that threshold where we know at that level exposure will cause permanent damage of some sort, whether it's a reduced sense of smell, eye damage, etc. And the thing you got to know about H2S is once oxygen enters that equation, and you have H2SO, 4 is the number. If you have enough oxygen, that's essentially the exact same chemical composition of sulfuric acid. So sulfuric acid, also known as battery acid, burns through the skin, creates serious havoc in mucous membranes because they're soft and absorbent, and acid inside of membranes is a bad mix. So that's another issue that a lot of people don't know, is that chemical composition is seriously damaging to the body. SO2, as I mentioned, it's half the PEL of H2S, so 5 is your PEL and 50 for your IDLH. Some places say 100, but it's definitely within that range of 50 to 100. So just kind of putting this into perspective of how small a 1 part per million is, it's like comparing an inch to 15.5 miles, or a second to 11.5 days. So basically from now till next payday, that's pretty much 1 second to that distance. That's kind of the ratio we're talking about here. So it's a very small number. Then 10 parts per million, 10 seconds compared to a pay period. 100 seconds, a minute and a half to a pay period. That's where our IDLH is. So it doesn't take a lot of it. And the issue with well sites and oil and gas is not if H2S is present. It's how much. That's what we're thinking in. It's how much of this stuff is out here. It's even in our bodies because we have decomposing organic material, which is how it's formed. Potential exposures include operations during drilling, transportation, gas processing, as well as production. It's present in crude, produced water, natural gas, typically the 3 things that come out of the ground when we're producing oil. And it's also present in other industries such as coal mining, trenching, sewage treatment, landfills, paper mills, and even animal processing facilities where you have blood and other decomposing material. You'll have some levels of H2S. And obviously how much of that material, how long it's been there, what other, what's in the air, what other gases are present, that's all going to impact how much of that chemical we see. So 3 factors affecting the acute health are essentially the immediate health concerns for people when we breathe it in or it gets on our skin. As I mentioned before, not if, but how much, the concentration, duration of exposure, and subtle difference is your individual susceptibility. Now we're talking a 5 to 10% difference here. We're not saying, oh, one guy can be around 10,000 parts per million and Billy over here, he's down at 100. That's not the range we're talking about. We're literally talking the difference between 10 to 15 parts per million typically, even up to maybe 100 from one person to the next. So just kind of be aware of that. Definitely fatal. One thing it does, because it's once again sulfuric acid, which sucks up oxygen, the blood is not going to be carrying oxygen through itself at this point, because it's also reducing the lungs' capability from creating air into oxygen for the blood. Also causes asphyxiation for two reasons. One, it burns the lungs out. Two, it shuts down the message in the central nervous system that says open, close to your lungs, which is an important message to be passed. That's right there in the nervous center of the brain, or the CNS, which controls breathing. And then also paralyzes the sense of smell completely. Like, once again, mucous membranes inside of your olfactory system, it burns all that out. On your skin, that acid type material, that oxidization, is going to form sulfuric acid and burn you. And in your eye especially, this is serious. So eye injuries are typically pretty common from H2S exposure. So if you're not necessarily hit with an amount that causes immediately dangerous to life and health, or someone to pass out or expire, there are, even at lower concentrations, long-term effects. Now, just like most diseases, and I usually ask this in classes, what do these symptoms look like? Headaches, dizziness, nausea, vomiting, pain in the nose, throat, pain in breathing, slowed pulse, fatigue, issues breathing, digestive problems, cold sweats. Most people are going to say, that looks like corona, to which I'd reply, yes, because our body only has so many different ways of telling us that there's a problem. And when that sulfuric acid type base, hydrogen sulfide, gets into our body, it wreaks havoc. Everything starts to shut down. Your body's going to turn red. I mean, it's your eyes are going to hurt, turn red. It's letting you know you need to get out of here. This is not a good situation for you. And as I mentioned on the eyes, it can, essentially a smaller variant of that same problem is going to occur. As I mentioned, individual susceptibility does play a role to some extent. The factors that are going to affect that are age, body mass, overall physical condition, smoker, non-smoker, personal biochemistry, any other gases in the blood, or reduction of oxygen in the blood will also cause a problem. So when you drink, for example, your blood thins, and that means there's less oxygen moving through it. So if you're going to be working around an H2S environment, whether you're doing confined space work, testing, roustaboutting in a well, in a sour well, plugging and abandoning a well, if you're in that world right now, you want to think twice before drinking the night before. In some cases, they even say 3 to 4 days, like don't even mess with it. So just kind of be aware of that even much smaller concentrations, when you don't have blood moving through your system, enough oxygen and blood moving through your system, can cause a problem. So H2S concentrations can vary from small to very large amounts. I kind of already mentioned our odor thresholds there. And even at 2 to 5 parts per million, a little bit of nausea, eyes tearing up, headaches happen. From 20 to 100, that's where we're going to start getting fatigue, loss of appetite, digestive disturbances, etc. Now, once again, 100, that's our IDLH number. And those are the numbers I really want you to remember are 10, 100, and 1,000. 10 is your permissible exposure limit, PEL. 100 is your IDLH, immediately dangerous to life and health. And 1,000 is DRT, what I like to call dead right there. Basically, anybody breathing in 1,000 parts is not making it out of there alive. Or if they did, it would be an absolute miracle. And it's good for us. God loves oil field guys. So, maybe you'll do all right, but 1,000 parts per million, we're definitely testing that situation. So at 100, this is where we start to, really have some serious issues. Coughing, eye irritation, total loss of smell, altered breathing, drowsiness, throat irritation, etc. So even death can occur at that level after 48 hours. Number, obviously, we want to be very cognizant of. 100 to 150, loss of smell. 200 to 3, 100, marked conjunctivitis, respiratory tract irritation. 5 to 700, you're going to be falling over, staggering, serious damage to the eyes within 30 minutes, and death within an hour. 7 to 100, that's where a lot of people are going to drop in this range, and that's where we see, when we do testing after some incident, typically we're finding anywhere between 700 and 1,000. and then 1,000 to 2,000, basically that's it. Now, at this point, we're not even at 1% H2S, right? We're at 0.1% or 0.2% at 2,000 parts per million. So we're at a very small calculative number of H2S before people are expiring. So keep that in mind as well. It does not take a lot, and H2S in bacteria can fill, the atmosphere and that gas pretty heavily. So just be aware of that as well. So for all these reasons, we've kind of covered what H2S is, how it affects the environment, how it affects us, parts per million, the whole gamut. For all these reasons, it's extremely important that we have a plan of action if something goes down. We know there's H2S on a site. We need to have a plan of what happens if Billy goes down in the treater, near the tank, inside the tank. That is not a time to be figuring it out. Like, oh, shoot, who's calling 911? Who's going to get him? Who's going to drive him to the hospital? Do we have a medical person that we can call that knows about H2S? Because you call 911, they're not going to be able to walk you through an H2S emergency like they are through CPR or a burn or something where it's typical. They're going to have no idea what you're talking about. So having the right people in place prior to that work is extremely paramount, as well as where the rescue area is. Do we have the equipment necessary? Is somebody trained to rescue, etc.? So all these things are going to be part of your immediate action plan. This should be part of your H2S program, your hydrogen sulfide awareness program. If not, definitely get with your safety personnel, your supervisors, and let them know. So if somebody does go down and there needs to be first aid, let's say we can pull him out by a rope, he's hooked up to a harness, and we can just get him out of there. Make sure that you're obviously upwind before you do anything. 911 needs to be called immediately. You should have somebody already designated to call 911 before you go in. Move the victim to fresh air. If stopped breathing, perform CPR. And typically with mouth-to-mouth resuscitation, we don't want to do that without a one-way ventilator, obviously, because we can breathe that in. It'll be in the lungs, and we can suck that in if we're not careful. So you want to make sure, once again, as a part of your rescue plan, you have a one-way ventilator built in. First aid measures. If it gets in the eyes, like most chemicals, there's not a whole lot you can do. You're going to flush it for about 15 to 20 minutes with a saline solution designed for this purpose. Those little bottles we carry around with us in our trucks are good for mild stuff, kind of a quick rinse. It's not going to last you 15 minutes. So once again, if we're working around high-level H2S wells, we want to have additional equipment out there that we typically wouldn't bring with us every day. So we kind of went through the health side, and I talked a little bit about the physical characteristics of H2S, but with that hydrogen embrittlement and the iron sulfide, well, when H2S passes through old pipes, and we remove that during roustabouting, or maybe remove some material during plug-in abandonment, for example, any air that gets in that system, if it's not essentially flooded, will dry that out, and iron sulfide will have the necessary element for spontaneous combustion, which is oxygen. So if you are pulling old tubing, old casing, old flow lines, anything where air can be trapped in there, you definitely want to cap it and flood it with water so that no oxygen gets in there. Otherwise, you may have a trailer that lights on fire when you're driving down the road, which is not a good day for anybody. So also on the edge of location, this can happen. So even treaters, etc., you're removing those and stacking them up. You want to make sure that they're full of fluid, or essentially you prevent oxygen from getting in there before you transport that material. Also, on this note, old tank batteries, especially if it's on an older well site, you never ever want to stand on top of an old tank battery lid that's been out there for 20, 30 years. A terrible idea, because it will eat through and a lot of you seasoned oil field guys know this, it will absolutely eat through the lid of that tank. And you do not want to fall through an old tank. There's not a ladder inside, I promise you. You're going to have a really rough day, and then obviously oxygen deprivation, etc. So for that reason, never, ever, ever get on top of an old tank without the proper, kind of platform materials before you go out there. All right, so oil field companies operators are required to test their wells and then have that information available. Typically once a year. Sometimes they take a little bit longer to test those wells, but anyone that's under 10 parts per million does need to be reevaluated every 3 years, just to make sure that that those levels aren't climbing. As far as personnel, when we go out there, we have to have some sort of monitor. H2S monitors used to be kind of the thing, but a lot of companies now are moving towards the 4-gas, and we'll look at this a little bit later. They need to be in the breathing zone, which is typically 6 to 9 inches from your mouth and nose, in kind of a circumference area. Medical surveillance also, if you got guys working around H2S a lot, you want to kind of consistently stay up with their pulmonary function to make sure that even at smaller exposures, it's not causing permanent damage. And that is all part of the healthcare program, your 1903 record keeping, and you do have access to those records if you are getting those tests at any time. Some other things we do to protect or prevent H2S from causing problems is we'll do things such as using weir systems and essentially filling systems with water or sometimes even a blanket gas to prevent H2S from coming out. And then we can control it and kind of divert it where we want it to go. Also vapor recovery units, alarm monitors, either in tank or outside of the tank, remote gauging systems so we don't have to climb the tank, and even things like mobile LACT units on oil buying trucks, so that that's just a part of the system down on the ground, so they don't have to go up and do a grind out and determine the specific gravity and other qualities of the oil. Engineering controls as well. We have H2S scavenger, which is typically a chemical that will essentially break down the hydrogen and the sulfur. Sulfur drops out, hydrogen goes away. Air blowers and ventilation. Also, like I mentioned, vapor recovery units. Essentially, all the vapors from the tank will just get pushed to the flare. And these are different systems, as well as fencing, etc., that we'll use to kind of keep people away from H2S in the first place. Some administrative controls. We have windsocks. Currently, North Dakota is moving on the high level H2S wells to have a red and white striped windsock for everybody to see that, hey, before I even drive up there, before I can even read the sign, if I see a red and white windsock, I know I'm over 100 parts per million. So that's a really good tip and trick there, or tool that they're using, and a tip to us to know whether or not we're entering a high hazard area. Also signs, labels, I mentioned muster point signs. Your sign is going to look like this for H2S, danger, H2S poisonous gas. When you see danger, that means something. 1, that means there is H2S. 2, that means it's at level high enough to cause permanent damage if you're exposed to it. So when you see this, don't bypass it. Some companies in the past have put these on every site, which I'm not a big fan of the boy who cried wolf, because it kind of breeds a little bit of familiarity and contempt. But if you see this, just treat that well as if it's high levels of H2S and you don't know where it's coming out of. So right here on the respiratory protection side, this is essentially a cascade system. So you can put these next to the stairs, going up to the tank battery, next to the treater, next to the wellhead at times, inside of a trailer, on the back of a truck, any different which way. And it's going to give you a certain amount of working air pressure so that you can work for long periods of time around H2S. Also included as an SCBA, the lines, some manifolds, typically pressure indicators on the tank, so that if it starts to get below a certain part per million, or a certain air pressure, it's going to kick off and ring like a bell. It's going to tell you, hey, our air pressure is getting low. So there's a lot of different parts to the cascade system. Some other things we do to determine H2S levels on the testing side is we'll use ray tubes. We also use 4-gas meters with pumps. 4-gas meters with pumps only go up to about 500 parts per million, so those are electronic, pretty easy to use. If we go over that, we have to use, essentially they call them ray tubes, but a lot of different brands make them. They have a little gel silica inside that glass. You break the tips, you suck it through what looks like a small bike air pump or ball air pump, and as that air draws through, any H2S chemical is going to change the color of that gel silica, and then to a certain degree, concentration, mark essentially your threshold or your level of H2S. These are not perfectly accurate. Typically, we say they're about 75 to 85% accurate. So you're going to lose about 15 to 25% through these, just because temperature, how many pumps you do, how cold the tube is. There's a lot of different factors that are going to affect the accuracy of these tests. All right, for your skin, typically whatever's going to protect you from salt water, oil, invert mud, etc., is going to protect you from H2S. So nitrile, any sort of PVC, etc., if that anything splashes on you, it's going to protect you. FR and other fiber materials, it's going to absorb into. And even if it doesn't have enough heat for it to come out of, such as in the winter, if it gets on your gloves or your clothing, get in the pickup truck, turn the defrost on, it's probably already on to high before you get in, or the heat. That heat's going to draw out that gas, and it can fill the cab of your vehicle. So be aware of that, especially if you know you're working on an H2S site. Get some water or some oil splashed on you. You definitely want to change out of that before you get in your pickup truck, and just get a new pair of gloves. All right, so our rescue personnel do need to be trained and have the right equipment. So trained people are going to know what equipment to bring. Non-entry rescue methods are kind of our typical method that we want to use, where we got a line on a guy if he's in a dangerous area, and we can pull him out without having to send someone in with rescue gear. But if you are a rescue person, you should probably know this. They can't leave for any reason. They got to stick there on site, and your standby personnel, once again, are just kind of ensuring that nothing's wrong. And they can turn from standby to rescue if necessary. So we talked a little bit about detection equipment. Typically, these are set at 10 parts per million and wore by everyone on site. A lot of times, we're going to use 4 gas meters in today's economy. They're measuring for LEL, CO, H2S, and oxygen. And these are all set, once again, to hit at either 10% of the permissible exposure limit or 10% of the LEL. So, except for in the case of H2S, that's going to be 10% of your IDLH. So you don't want to use these necessarily for a permanent fixed monitor. You don't want to tape it to the side of a tank or stick it inside of a tank to measure. You want actual gas detection systems to do. Here's an example of one that we use. This is a remote monitoring system. The monitors in the middle there can be encased in magnetic housing, put around the rig, in the cellar, at the shakers, by the rig floor, downwind of the flare, wherever you want to know if H2S is present. And then on the left you have a controller, and then it's all linked to an alarm bar. It's going to blary sounds. Lights are going to go off in different orders. A slower white light means low level H2S. Faster orange light means higher level, between 10 and 20. And then 20, and then essentially 30 and above, you're going to have pretty fast, rapid blaring sound, and then the red and the white are going to flash. So, and those can be configured a little bit different, but that's the typical method, just so we know. So if a monitor goes off, what do? Move to the muster area. Do not re-enter the work area until it's been cleared by a supervisor, it's been tested, etc. So some people, the challenge is they don't calibrate and bump test their monitors regularly. And as we all know, sometimes their monitors go off just sitting inside of our truck for no apparent reason. And so what can happen is we're out there working and we're like, oh, it's just going off again. What? This thing isn't working. You do not want to have a monitor that you cannot trust. You know what I mean? It's like dating somebody who you cannot trust, or marrying somebody you cannot trust. It's going to be a rough life. You have a monitor that doesn't work, you're going to have a rough life. So definitely get that fixed. Oh, if only relationships were that easy to fix. But monitors, definitely pretty easy to fix. Take it in the morning, give it to your safety guy, bring it to a safety outfit, let him get it bump tested and calibrated so you can trust that it works. So lastly here, before we wrap up, emergency plans, extremely important. As I mentioned before, we want to have everything in place beforehand. It does not have to be a 30-page plan. It can be very simple. In fact, I think the simpler the better, but you need to have roles identified, muster points identified, known wind directions identified. Some of these get super intense where it's like dispersion rate based on pressure coming out of the well or out of the tank, and what the wind speed is and direction and where it's going to go, and you got little maps. You don't need to do that on a typical job. You can keep it really simple. Here's the west is coming from the north by northwest. That's where our muster points are. We want to park all trucks upwind that way. Billy's driving someone to the hospital if they go down. If Billy's the guy who goes down, this is the person driving them. This guy's calling 911. Here's our rescue guy. We've already alerted the hospital. We have an SDS of H2S with us, because once again, medical personnel aren't always going to know how to treat someone with H2S just offhand. So SDSs typically give a little bit of treatment information on there as far as first aid. So that's important to have with you as well. Also, non-audible signals for if there's gas or H2S. If it's a really windy day, Billy's downwind, working around a tank, and his monitor goes off, you're not going to hear that 30 feet away. It's just not going to happen. That wind's going to be whipping by too hard. So you should have some sort of non-audible or visual signal for gas. And typically it's almost looks like 3 jumping jacks, 3 waves of the air or of your arms in the air. That's typically the kind of known method. So you want to establish some of those as well. And then how to report and, H2S emergencies, other emergencies, pretty similar. Roles identified, where people are going to go, and what you're going to do with them once they're rescued. All right, so wrapping up here and summarizing, H2S is present in many of our areas in the oil and gas industry. It's toxic, it's flammable, can corrode metal and cause severe stress cracking, and then ultimately iron sulfide and spontaneous combustion. It's important to become wind conscious at all times. If there is a gas release, first thing you want to do is not panic. Second thing is hold your breath and leave the area. Now, this isn't like take a deep breath and then hold your breath. It's like stop breathing now. Heads up, getting more than 100 feet, if you just stop breathing mid-breath, is a challenge before you have to breathe. Some people can do it, most people can't, especially if you're a smoker. This is something you want to consider, is how long can I hold my breath. Move crosswind and upwind, and obviously protect yourself first. Sense of smell, no go in detecting H2S. Not going to work for you. Make sure you have a monitor on. So kind of some of these numbers that are important, especially for the quiz here. 10, 100, 1,000. Pretty straightforward. PEL is your 10, that's permissible exposure limit. 100 is your IDLH, and 1,000 is your DRT. That's not going to be on the quiz. DRT is something I made up, but just so you know, that's kind of our highest threshold where no one's really surviving past that. So lastly, if we know H2S is on a site, you want to have that, your emergency plan discussed every morning as a part of your emergency action plan and JSA, and who's responsible for what. Gas monitors need to be calibrated and bump tested, and we want to have a minimum of 1 muster point. Sometimes you want to have 2, just because wind direction changes. So we want to be looking where, typically we use the entrance of location, but that's sometimes downwind, which can cause some issues. So that's typically where you want to have your rescue equipment as well, is where your muster point is. Well, that's all we have for this month, ladies and gentlemen. Thank you very much for paying attention and being a part of our training. As I mentioned before, quizzes can be a little bit longer this month. If you have any feedback or information you want added to this presentation for the future, or anything else, please leave that comment in the bottom of the quiz, and we'll also get you your cards this month. So expect that for somewhere around the middle of October. Everybody have a great day. Thank you very much.